Hi guys, my name is Rahil Parikh, and the topic that I've selected for my RDBMS IA-1 is optimizing natural language interfaces for relational databases. That might sound a bit complicated, but actually it's not. It's quite simple. In the research paper, what the authors have done is that they've taken an input in the form of a natural language, like an English sentence, and they have converted that input into its corresponding SQL query format. To do this, they have used natural language processing NLP, and they've made use of RNNs, which is recurrent neural networks, and the data they had collected from WikiSQL. So basically, let's just understand what neural networks are first. So basically, it's like neural networks work similar to the neurons in your brain. Like this is an input, then this is a hidden layer. So this is where the training of the neural network would take place. And then that data would be passed and you would get the output. So recurrent neural networks are a bit different than the traditional neural networks. So basically, initially, the model is trained, the input is given to it, it gets trained, and the output is given. But they use something called as back propagation. So in case the output is incorrect, it will kind of send that data back into the network so it can get trained again, and the model parameters would get updated in this hidden layer. And once that is done, that data would again be sent forward to the output. So basically, the entire point of this back propagation is to reduce the errors in the neural network. So basically, that's what the authors have used. Now the neural network they have trained on this wiki SQL database, which has questions, SQL queries, and SQL tables. And they have also applied a lot of pre-processing. So they have used something called natural language processing, and in that basically they have removed the stop words from the sentence. So stop words are like the most common words in English, like the, for, and, can. So those words were removed because those words aren't very important. And then the sentence was POS tagged. POS is parts of speech. So all the important words in the sentence, they were separated into categories like adjectives, verbs, singular, plural, like that. And this is just another diagram of a neural network that has the back propagation. So basically what they've done is any English sentence you can give to the model and it will give you the SQL query. Now the methodology that they've used, so they have created a web portal. So as I had said earlier, you just have to input a string in English, and it will convert that string in English and it will output it in the form of a SQL query. So basically what they've done is it has the web interface they created. It has three parts: front end, back end, and database. So front end is where you give the English sentence input, that is pre-processed and a bit of NLP is applied on it. That input is then passed to the recurrent neural network, and whatever output that gets generated in the form of an SQL query is sent to the database. Now that query is executed in the database, and whatever result you get from the execution of that query, it is sent back to the user in the front end. Now, this is just another diagram. Basically, it describes a bit more in depth the working of their entire research paper. So this is the input, the string, the speech or text command, which is the input. This is the natural language processing part. Then the recurrent neural network generates the SQL query, and that gets executed in the database. So now these are the results. So one of the good things is that a user without any technical background can also retrieve information from this database. And this is just an example that they had given in the paper for the results. So the natural language input is who is the player that wears the number 42. And then the recurrent neural network generated this SQL query, select player where number equals to 42. And then this is the data sent to the user in the front end. Art Long is the name of the player that wears number 42. And one more thing is that in the paper that they do not mention the accuracy in terms of percentages, or they have not specified the entire architecture of the recurrent neural network, like how many epochs, how many iterations, how many hidden layers are there. They have simply put this in the form of a result. So that is what I have shown to you over here. Now the conclusion is that the natural language input in English given to the system will get translated into its corresponding SQL query. Now the neural networks have been trained on the Wiki SQL database, and user inputs apart from natural languages are minimized. So if you like enter special characters and stuff, that is not considered because it can like confuse the neural network. And one more key thing is that when there are any ambiguities encountered, the system would give you multiple interpretations of that. So the user can choose the correct one from that. And that will kind of help the recurrent neural network learn more because of the user feedback. Now, this is some of the future scope. So obviously one of the main things is that we could minimize the need to write complex SQL queries. And then obviously improving the accuracy of the recurrent neural network has to be something that we work on, like increasing the number of iterations, epochs, maybe the hidden layers might improve the accuracy. And deployment of the model on a website or any kind of mobile app would make getting information from the database very easy, because all you have to do is type the information you want in English. The neural network will convert it into an SQL query, execute it against a database, and then just directly give you the output. So this is just the bibliography. Like these are some of the links I had referred to while creating this PPT. So yeah, thank you. That's it from my side.